Fire! Front! Stop! Please.
Hello and welcome to Bloke on the Range, and I'm very happy to welcome back Dale, the Sturmgewehr 57 and rifle grenade expert, for another episode, this time specifically on the rifle grenades, including these scary flying carrots of doom.
Correct.
So very glad to have you here. Thanks for coming.
Nice to meet you again.
Bringing all your stuff up here. The angle of the camera is such so that we can see as much as possible of what's going on, and we're trying to be multimedia here. Dale gave this presentation in French to the Vaud section of the ASIA.
That's correct.
Collectors organisation that we're both a member of. And it was fantastic, so he agreed to translate it into English and come and present it to you guys. Now, pour yourself a cup of something. This is going to be an epic. We've got screen cap from Death by PowerPoint behind us. I'm going to have to spend quite a lot of time editing the PowerPoint into this, but hopefully it's all synced up. Hopefully it's all going to work. Hopefully it's not going to take me 86 hours. But
I'll try my best to help.
Let's see how it goes. So this is all a bit experimental. What I did previously when I did my HBSA talk inserting JPEGs was just a complete disaster and nightmare. So hopefully this will work better. If it doesn't, I'm terribly sorry. So, Dale, if you would like to
Yes, sir. Well, thanks for having me again. It's always a pleasure to be on your channel. And so today we're going to explore the world of the M58 rifle grenade, or Gewehrgranaten 58. And so we're going to explore this in kind of a 360-degree approach. So we're going to talk about the technical aspect, the historical aspect, and then more of the handling, doctrinal aspect. So it's going to be split into 2 episodes. This first episode is only going to treat the historical and technical part. And hopefully later on, the later episodes, we could actually demonstrate firing techniques, not live fire, for the YouTube police.
yeah, just dry.
Just dry, exactly.
Everything here is inert.
Exactly. So there's no risk of, we're not smokers, we're non-smokers, so we shouldn't blow anything up. All the ammunition is marked inert. We can show this later on. So we're good to go. So,
right.
Let's get going.
Yep.
Okay. So it's going to be split into 2 chapters for clarity. On the screen cap you would see there's going to be a progression bar on some of the slides so you don't get lost. Especially on the technical aspect, because in my opinion there's a lack of information on these projectiles on the internet. There are no books written about them, so everything was done with archival research. I won't go through all the time and post all my sources. It's going to be 26 pages long.
Yeah.
So for those of you who are interested in the sources, you could send Mike a message and we can share this information to you. So we're going to start with historical context and next the technical description and evolution. Now for the historical context, it is interesting for us to first explore what is a rifle grenade, how it works basically to get the basic terminology right. And then we're going to focus only on the Swiss perspective. So when did the love story of Swiss rifle grenades start? And in my opinion that's pretty interesting because it makes sense since the M58 rifle grenade is a natural evolution, continuation of the Swiss trials during the Second World War.
And just to go back to the previous episode on the Sturmgewehr 57, the ability to fire massive rifle grenades was part of the design brief and is a large reason why the rifle is like it is. It really comes down to the design of practically every part. Because let's just say that an FAL is not man enough for these puppies.
Correct, yeah. So for those of you who haven't watched the previous Sturmgewehr 57 episodes, we urge you to do so because it'll give you a more rounded picture on the actual launcher, not assault rifle. We treat this as a launcher now. And it makes more sense if you understand why the rifle is as it is. So let's start with the basics. What is a rifle grenade? So it's an individual support weapon. So it's designed to augment firepower. The platform is preferably just standard issue weapon. It should not be any sort of a complicated mechanism, just a simple standard issue weapon with minimal modifications. Effect is explosive, could be anti-personnel, anti-tank, or even special. You have smoke grenades or even illuminating grenades. Some countries did that also, or practice rounds. And it could be used both in direct or indirect fire for different purposes, which we'll explore later on in the next chapters.
And ironically, you've used a picture there of a British
I think it's
sergeant instructor, by the look of it,
exactly.
with an Energer,
Mhm.
Energer rifle grenade on an SLR.
Exactly. So I think that's a pretty good picture. It illustrates that pretty nicely. So from a technical perspective, how is it done? How do you project this from that? And so when you design a projectile, there are 4 different considerations. First one is platform, launching interface, the energy source, and the eventual complications from this energy source. So in terms of rifle launch projectiles, there are 2 different approaches. The first one is a standard issue weapon approach, which here is a Sturmgewehr 57, or could be an add-on grenade launcher, which is the case of the M203 or GP25.
Yeah, that's the sort of modern solution.
Correct, yeah. So nowadays the rifle grenade is kind of passé.
Even the French with they've adopted the HK416,
Correct, yeah.
which again isn't man enough for rifle
I don't
grenades.
think
really.
I don't think it has any rifle grenade capability. Although I think it has a spigot, if I'm not mistaken, just in case. It's the F configuration, but that's a topic for another video. Next consideration, and now we're going to talk only about the standard issue weapon, is the launching interface. How do you interface this with that? And there are 2 ways. The first one is using what's called a discharge cup, in French or in German, tromblon. It's basically a big ass tube, and the projectile goes inside and is projected. So it's basically an extension of the barrel. The second version is called a spigot, which is a under caliber system, meaning the projectile fits over it and then is propelled. So it's an inverted barrel per se.
And people will mention rods, but rods were out partway through World War I because they trashed the barrel. So
Exactly.
we're not considering such obsolete things here.
Exactly. Now, how do you propel said projectile? The basic idea is always the same. You use the gases of the projectile, of the cartridge, sorry. And so you can either use a standard ball cartridge or a launching cartridge. So basically a cartridge with no bullet. But the thing is, if you have a ball cartridge, from an engineering perspective, how do you deal with the projectile? And there are 2 main ways. You can either use a bullet through or a bullet trap configuration. So an example for a bullet through configuration would be the VB or Vivant Bessières rifle grenades. And the bullet trap will be, for example, the Lucher French grenades or the Telgren, the FN Telgren. But it's a pretty complicated process. In the Swiss M58 rifle grenade family, these are all done via spigot, right here, done via launching cartridge, and that's basically the end of it.
One complication of a bullet trap or a bullet through design is it limits what you can do up at the business end, because you have to have the arrangement to stop the bullet or the passage to let it through. You're not free to choose. From a safety perspective, in combat, of course, it's great. From a safety perspective on a practice range, it's less great, because you've got people firing bullets at high angles. But I think given what the Swiss wanted to achieve with their family of rifle grenades, going to a launching cartridge was probably their only option, really.
Exactly. Yeah. Considering the logistical aspects and the fact that they committed to this system during the Second World War, we'll discuss in detail after.
Just wait till you see the complexity just to do what they do, and that's without a bullet trap or a bullet through.
So get your coffee ready, because we're in for a ride. Now let's talk about basic rifle grenade anatomy. Now, of course, there are many parts as number of rifle grenades. So we're going to talk generally speaking. So basically there are 3 parts. You have the ogive or ogive, depends where
Depends on who you're asking.
I say ogive. The stabilizer, which is the interface with the barrel. I can show the demonstration here. And of course a stabilizing fin, which could be plastic or steel or some material. The idea is creates drag into the rear and basically leverage on the projectile to stabilize it on the axis of flight. So these are not gyroscopically stabilized projectiles, unlike bullets, because this has to do with the construction and also the fact that some of these are hollow charge projectiles, which are sensitive to this kind of gyroscopic rotation. And the idea is simple. You basically have, here we have a Sturmgewehr barrel that is opened up in the chamber, so no worries. The idea is pretty simple. You fit the rifle grenade onto said spigot, and simply by the gases of the launching cartridge, you fire it off. Well, except using my lungs, you actually use the chemical energy of the propellant. And you can do a lot of stuff with this, and the projectile is launched at a pretty good velocity. We're going to explore that later. Now, let's focus more on the historical aspect, more importantly, the Swiss perspective. So, the love story with Swiss rifle grenades started during the Second World War, and we're going to explore that. And then, after the Second World War, in the early Cold War period, that's when things really started getting moving, especially because of the social and socioeconomic and political situation. There was a great need for rapid advancement in technology, and the Swiss really took that into consideration. So, let's start with the start. So, during Switzerland's involvement during the Second World War, which is roughly 42 to 45, there was a distinct lack of anti-tank weaponry. Simply, the Swiss were not equipped for so-called blitzkrieg modern war. So lots of armored vehicles and armored personnel carriers. The Swiss were not able to deal with this because they had a limited number of field pieces. They had no individual means, and this also has to do with the economic situation of the country, since Switzerland was not very rich at the time, couldn't really afford to develop these kind of weapons. And so that means weapons that do tend to be developed are rapidly obsolete because armored technology kept improving very fast during the war. And so the Swiss were kind of in a precarious situation. Now, the sort of emergency or patch-up solution to this problem is what's called the Tankbuchse 1941, or the anti-tank Harquebus model of 1941. It's crazy. It's basically a semi-auto only LMG-25 chambered for a 24mm shell. I think Ian did a video on these. Yeah.
Yes, I think he did. And yeah, it's a Fura thing, so it's got a toggle.
Exactly. It's absolutely gigantic. It feeds from a magazine that's basically the size of my chest. And so, just, you can see the weight on this thing. It's about 150 kilograms ready to fire, so it's definitely not a man-portable device. It's on a carriage, and the performance is okay for a standard inertial weapon. You get 30 millimeters at 200 meters. So,
which for 1941 isn't bad.
It's not bad, yeah.
It's certainly better than a boy's anti-tank rifle.
Exactly. So you can probably defeat a tank from the side or from the rear, probably on the front for some earlier models, but it's respectable, especially when it's semi-auto and you have a repeat shot capability. But as the war went on, it kind of dragged on. So I just want to show you some pretty cool archival footage of this thing in action. It'll give you an idea how big this thing is. And
bei feldmäßigen Schießübungen macht sich der Büchsenmacher mit dem Stellungsbezug und der Verwendung der verschiedenen Waffen vertraut. Im anschließenden Parkdienst übt er das zweckmäßige Reinigen und Instandhalten der Waffen.
so yeah, that pretty much illustrates the point. This thing is absolutely gigantic for the effectiveness.
And the irony, I love it. It's the same with the bunkers and things like that. All the steel that went into things like that to defend against a German invasion had to come through or from Germany.
Well, how's that for irony?
Mm.
Pretty crazy stuff. Now, if this allows me to move forward, there we go. So basically, that was the Swiss situation on the military perspective. It was pretty dire, to be honest. But luckily for them, they had a dude who could solve their problem. And this dude's name was Edgar Brandt. So he was a Frenchman, metal worker, inventor, engineer, entrepreneur. Actually, during his World War I service for France, he made lots of innovations, especially in the mortar and projector type weapons. So compressed air. And he also invented the Stokes-Brandt mortar, which is basically the pattern of the tube with the base plate and the bipod, which basically defined what a mortar is for the next century or so. So pretty influential dude. Now, we're going to see later, he tweaked around with these kind of rifle grenade projects. And what happened was he founded a company in Switzerland called CML in 1942, Construction Mécanique du Léman, the Léman Mechanical Workshops. And at the same time, and that's some foreshadowing here, in 1943 in Vaduz in Liechtenstein, founded a company called Energia, which is a patent filing company. The sole purpose of this is to secure patents for large geographical exclusivity for business, basically. So this dude had a pretty good business acumen. Now, Edgar William Brandt kind of was a very clever guy, and he came up with some systems that really resemble what our modern conception of the rifle grenade is, which is a simple spigot mounted on here, a MAS 36, and a projectile that is launched with a simple cartridge with no bullet. And this was called the Grenade à fusil à charge creuse modèle 1937, 1937 model. And they tested these in France in the 1940s, and the performance was astounding. 40 millimeters of penetration for something that is launched from a rifle. So it was inconceivable. And the French were very interested, but the problem was Germany invaded Free France in 1941. And that's when Edgar Brandt fled to Switzerland and founded CML, the company, and continued this work in Switzerland. Now, he continued this work in Switzerland and proposed this system to the Swiss government, which is the KTA, or Kriegstechnische Abteilung, or basically the War Material Department. The first iteration of the Swiss rifle grenade is called the Panzerwurfgranate 44. We have a practice version right here, so pretty basic stuff. And the performance was incredible at the time. It was 100 to 130 millimeters of penetration, so it could defeat almost any tank head on, up to a range of about 50 meters. And it weighed about 700 grams, projected from the standard K31 short rifle, or later on K11 short rifle. Now, in order to launch this rifle grenade, the Swiss developed a specific cartridge, which was declined in two variations. Two of them were called the Gewehr 3 Patrone 44, or the launching cartridge model 1944. So what they did basically was take a GP11 case, made it longer to make a fake bullet section for feeding, obturated it with a simple wooden cap on the end, you can see it on the drawing, and the actual propellant is about 2.25 gram of flake type nitrocellulose powder, so relatively slow burning because there's a lot of air to fill in the barrel before the projectile starts moving. And in order to not mix it up with standard ball ammunition, you can see they are tinned, so tin plated, and they have a slight knurling behind. I don't know if you can see it on camera. The idea was officially to recognize a projectile at night in low illumination. In my opinion, it's a bit far-fetched, but at least the idea was there. Now, this system was almost immediately adopted. The Swiss were very keen on this system because it basically solved their whole problem of short-range anti-tank defense. And so the system consisted of a spigot, you can see here, that could be simply fixed onto the rifle, and a special magazine that allowed only loading of propulsion cartridges and to avoid mixing up ball ammo and rifle grenade ammo.
And we don't have one of these spigots because a separate grenade launching spigot requires an exemption permit here.
Exactly. So
it's
go figure for the law, but that's the way it is.
An integral one, fine.
Exactly. So to give you an idea for the audience who are not aware of this particular system, we'll have a video compilation that I'm going to show later on. Now, the system kept evolving. The Swiss kept improving this particular projectile, even introduced a simplified and improved model called the Model 48, which is right here. Now, the Model 48 is basically the Swiss version of the Energia rifle grenade. They both use the same fusing system, which is point initiated, base detonated, and the similar fin arrangement that would be sold worldwide. So it was a huge commercial success for CML, who licensed it to Mekar, for example, or some other ammunition manufacturers all over Europe. And as you can see, the system was very popular because any infantryman, really, that was issued with a standard rifle could be trained to the system, and so that was the key to its effectiveness. Now, here's an incredible video compilation. It took hours of archival searching, but it's worth it. Some of this is silent video, but this gives you an idea how the system
Auch ein
works.
Karabiner leistet mit Schießbecher und Panzerwurfgranate versehen auf kurze Distanz gegen Panzer gute Dienste. Auf die folgende Attrappe wird natürlich blind geschossen. Auch der Umgang mit Panzerwurfgranaten wurde geübt.
Alle molteplici competizioni si saranno avute in totale più di 24.000 iscrizioni.
L'utilità della loro attività fuori servizio nell'ambito delle società regionali.
Questi uomini di prima linea sono specialisti nella lotta contro i carri armati. Le loro armi sono micidiali per i mostri d'acciaio.
So yeah, pretty crazy stuff. Huh? The guys back then had a lot of fun with the system. Now, there are several variants of these practice grenades. We don't have any combat ammo to show you, but you might have spotted in the video there was a second version that was fully rubber. So basically, the problem with these wooden and steel projectiles is that they were not very durable. And so they changed this to an integrally molded and integrated solid rubber projectile. So this was kind of the improvement that's called the Model 48 Exerzier Wurfgranate. So
Even the fins are rubber.
exactly, even the fins are rubber. And we're going to talk about the rubber fins later on because they trialed these with the assault rifles too. And so the system was massively issued at the end and after the Second World War. And to be short, it was not the most popular system because the rifle was never intended for rifle grenade firing. And therefore the stresses on the shooter and the weapon were simply huge. And people were crapping their pants before firing because of the intense recoil. So here you have a nice little postcard right here. And a little caricature that tells you what happens after a rifle grenade session. You had a lot of injuries. So here, we ran out of heads, but we still have 8 hands. But people broke their fingers off back then. Now, after the Second World War, what I noticed when studying the archival documents is that the War Material Department was much more open to the private industry and its proposition. So it was not only limited to the government industry, which was a tool and ammunition factory. And for example, Hispano-Suiza, which is also based in Geneva, introduced this prototype called the T-55. So the idea was, after the Second World War, to make these projectiles lighter and more effective. So that reduces recoil and cost and transportation, so on and so forth. Now, all these projects, which rolled around relatively slowly, accelerated significantly, as we mentioned before in the Sturmgewehr video, with the Hungarian Revolution. So in 1956, after an anti-communist revolt, the Soviets basically barged in to the country and simply shut the whole thing down with force. And that was a few hundred kilometers away from the Swiss borders. And as I said in the previous video, they crapped their pants.
It tightened the sphincters quite significantly.
Exactly. So it's like, oh crap, the Soviets actually did this. We need to hurry up because they might do the same thing for us, which is completely understandable. Now, one of the things that really propelled forward all of these modern infantry weapon projects was the Sofortprogramm, or the Emergency Program of December 1956. And there's an interesting quote that is extracted from this. For those of you who read French, I'm just going to go past to the English translation. First of all was the acquisition of new models of field guns. So hollow charge field guns that are effective against all known armor at the time, but also an improved anti-tank rifle grenade. So basically, that was the founding document for the start of development for our M58 projectile. Now, at the same time, in parallel, during the early 1950s, there was the assault rifle program. The original idea was to use an intermediate cartridge, and later in 1955, it was decided that it was too experimental, and they switched directly to the GP11 cartridge. And you can see that in the Rüstungsprogramm 1957, basically a program listing how the money will be spent on defense. And there's a quote in there that is interesting, talking about the what this new assault rifle would be, because we need an increase in firepower and also firing the ordinary rifle cartridge, and also should be able to fire the rifle grenade in case of a nuclear attack. So that was basically the mentality at the time. And so just to skip forward a bit, in 1956 there were basically two Swiss propositions. The Waffenfabrik Bern proposed the Sturmgewehr 55 and SIG proposed the AM55. Now, in terms of mechanics, both of them differ significantly. The Waffenfabrik Bern is gas operated, and the AM55 is much simpler, which explains its lower cost, and roller delayed, so very experimental for the time. And because of cost reasons, the SIG prototype was retained.
It's still very expensive, as we discussed last time,
Exactly.
compared to what anyone else had.
Swiss weapons will still remain Swiss. Now, just to show you a little bit about how this prototype is supposed to behave, this is incredible footage at the time of a demonstration of the AM-55.
Sur la place de tir de Wallenstadt, présentation du nouveau fusil d'assaut qui sert à la fois de mousqueton et de mitraillette. Cette arme est de construction simple, de ce fait le montage en est facilité. Ce fusil entièrement automatique permet aussi bien de tirer coup par coup, en rafale, qu'en tir rapide, à raison de 60 coups à la minute. Du fait de la faiblesse de recul de l'arme, sa précision en tir rapide est encore excellente. Chaque soldat d'infanterie recevra ce fusil, qu'il conservera chez lui, comme précédemment le mousqueton. Un léger bipied qui peut être déplacé le long du manchon du canon peut être utilisé comme support antérieur pour le tir en rafale. Cette arme unique a la précision du fusil mitrailleur jusqu'à un peu plus de 200 mètres de distance. Pour la défense anti-char, un tromblon fixe a été monté sur l'arme, permettant d'utiliser des grenades ou grenades fumigènes. Du fait de son poids d'environ 6 kg, il assure une grande liberté de mouvement. Par la même occasion, les fusiliers étrennent ce vêtement de combat. Les buts lointains sont atteints en tir coup par coup. On peut voir que cette arme donne une puissance de feu considérable aux combattants individuels. Et sur courte distance, le feu en rafale donne à la troupe une puissance défensive formidable.
So that gives you a good idea about the tough requirements for an automatic weapon. It had to be everything at the same time. A precision rifle, a light machine gun, as controllable as a machine pistol, and also able to fire scary carrots of doom. So the perspective on rifle grenades also changed during this 1956-1957 transition period. Basically, at the time with the K-31 short rifle, they basically only had anti-tank rifle grenades, nothing else. And so the idea was to diversify the portfolio of projectiles, which include not only anti-tank projectiles, but also fragmentation, so anti-personnel, and also smoke. So basically a trio of rifle grenades. And so development started in 1956 for this new requirement of anti-tank rifle grenade. Now, the very first models basically were the same, just improved fuses and improved hollow charge technology. Here there's a few drawings, original trial drawings at the time. But what really formalized and what would define the M58 rifle grenade as we know today are the February 1957 specifications, and they're extremely high at the time. The idea was this new projectile should be able to hit a 100-meter moving target or 150-meter static. I'll let you imagine the difficulty of that. And that means that the velocity of the projectile must be extremely high. Penetration off the charts, 300 millimeters. The fuse should be sensitive at 20 degrees of impact, which is very shallow. Sensitivity, 4 millimeters of cardboard, so very sensitive. Muzzle safety, shelf life, temperature, the whole 9 yards. In fact, that's a little anecdote. They're even designed to make the Sturmgewehr cycle, but this requirement changed during the time. And so this family of rifle grenades were called the Conception 1957, or basically 1957 design. And so the easiest way to obtain basically a higher velocity, or higher projectile velocity, is by simply increasing the charge.
More powder.
Exactly, more powder. So they try with double charges or different powders, basically the same case. And it didn't work very well. Now let me show you exactly what were the pros and the cons. So the projectiles that were involved were basically similar but had reinforced tubes to accommodate for the higher pressure. And they even developed a family of practice grenades that were basically modified Model 48s that were basically turned down to this new caliber. Now here are the problems with the Concepcion's 1957 is that it was accurate. The projectiles were light because it's a simple closed-end tube, handy and compact, but the problem is when you increase the charge inside of the cartridge, you get extremely high recoil. So to achieve a higher speed over the same distance it has to accelerate, well, you simply get more recoil energy communicated to the rifle. And so the troops complain of that. Second, logistical issues. Imagine what happens if somebody who is a K31 rifle grenade shooter accidentally puts a Sturmgewehr only rifle grenade cartridge and then fires it off. I'll let you imagine the consequences. And so it was too complicated from a logistical perspective, and from a simple practical perspective, the project was shut down. Now, what really changed the junction event that really changed this the perspective on the M58 rifle grenade was CML. So if you forgot already, CML was the Geneva company that was responsible for the development of ammunition. And they proposed in February of 1958 a rocket-boosted stabilizer. So let me explain. Instead of solely relying on the power of the driving cartridge, you would actually split the task. You would use the existing, so Model 44 driving cartridge, and then with a rocket booster, accelerate this projectile outside of the weapon. So it's semi-active in that sense. And that reduced a lot of the recoil that is being imparted on the rifle, since the projectile is accelerating outside of the weapon over 5 or 7 meters. And so 4 patents were filed for this new arrangement. We'll talk about these in detail later on. And so this kind of changed the perspective because the Swiss realized that this system worked very well. And they developed a whole family of projectiles around this M58 rocket-boosted propeller. And so this included anti-tank grenades, which we have right here, Panzergranate, a practice grenade with an experimental rubber head, even a smoke grenade and an anti-personnel grenade, which will continue to evolve to the projectiles we have today on the table. Now, of course, it was not without disadvantages. It worked very well, it fulfilled the requirements, even made the warheads interchangeable between the rocket launcher projectiles and the rifle grenades. But the problem was, when you add a rocket motor, it adds more error to the projectile, meaning that the tolerances of this rocket booster will stack up with the tolerances with the drive tube, and this results in misalignment, which translates to bigger dispersion of the projectile. So the projectiles were inherently less accurate. And also, you cannot guarantee that the rocket motor will burn out at the exact same moment or peak of flight of the projectile, which means you have large dispersion on elevation. That's something that was also noted. And you also add weight and cost and length, meaning that something that was, pretty short and handy becomes this. So let's talk a little bit about this evolution.